Learning objective 5 is cost behavior. We've seen these terms before because we're looking at the mathematical relationships between fixed costs and variable costs. So in the short run, we have fixed costs, things that don't change, sunk costs, which are costs that are spent in the past, variable costs, which change with each unit change in the unit's production, and total is simply adding together the variable and fixed. Now, in the long run, as mentioned earlier, all costs are variable, so we have no fixed costs because anything that's fixed we can change in the long run. The short run costs look like this. We have a fixed cost, a variable cost, and a total, right? Very similar to things we've seen in other courses. So fixed plus variable equals total, so it simply shifts up. And the difference here, this constant, is equal to the fixed cost. So average fixed cost is the fixed cost divided by quantity, and the average variable is the variable cost at that level divided by quantity. And the average total is add up all of the costs together, fixed and variable, and divided by quantity. And marginal is at the margin, right? At that spot. If you move up or down, what would be the cost change? So it's a change in cost at the margin where you change quantity by a very small amount, say 1 unit. Let's look at the relationship now of these factors. So when we look at the average fixed cost, we start here, which is fixed cost, but then it will drop because we're just dividing it by the output. So the more we produce, the lower the average fixed cost will be. The average variable cost will be dropping, but at some point the costs will be rising because we've hit a level where our costs are not as efficient and we're starting to have diseconomies of scale, and now we're going to be paying more. So our average cost curve, which is the combination of the two, has the combined shape like this. Fixed costs and sunk costs. So fixed costs don't change. Sunk are already spent. We can't get it back. And they're irrelevant, as we saw in our previous class. It's irrelevant because we can't do anything about it. We spent it. It's gone. We can't cry over spilt milk, if you will. In the long run, everything is variable. So the long run cost curves have this unique example of how we can achieve different levels of cost given the scale that we're seeking. Graphically, it looks like this. So this is where we were at, let's say, time 0. And at time 2, we can, or time 1, we can then have a different cost structure as we increase our output. And over time, when we get to time 2, let's say, we'll have yet more output with different cost structure. So overall, the long run cost curve looks like this, which combines time 1, 2, and 3. Learning objective 6 is economies of scale and cost complementarities. Economies of scale are where we have a declining portion of long-run cost curve as output increases. In other words, every additional unit we're building, we get more output. So let's see some of the graphs associated with these particular measures. The long-run average cost, if we look at the cost versus output over time, we could see that we could start with a cost curve where we see economies of scale, and then we hit a bottom, and then we start to see diseconomies. One thing you could do as a management point of view is to constantly look for improvements. So we could go on this curve. So as we're seeing our costs rising, we can embark on a new cost curve represented here by ATC sub 1, and then we could drive that further, knowing that at some point it may come back up, and that represents kind of a long run average cost that shows diminishing returns here and economies of scales on this side. So we see in summary that we just look at the endpoints, that the long run average cost curve shows this period where there's economies of scale hitting to a bottom and then thereafter going to the diseconomies of scale. We may also see constant returns of scale. This is a condition where we have ATC 1, where we bottom out right at this level, and we're able to maintain it even though our volume increases by finding new innovations to drive down our costs once again so that we can maintain this more steady constant return scale when we go to ATC 1, ATC 2, and ATC 3. So that would look at a constant return to scale.